The last way that atoms can hybridize is sp hybridization, and this comes about when the atom only has to make bonds to two other atoms, or maybe a lone pair in some cases as well. They count kind of the same as atoms, as we'll see. So for this carbon, for example, is only bound to a hydrogen and another carbon, so it only needs two hybridized orbitals to hold on to those two atoms. The rest of the orbitals are going to make those different types of bonds, which we saw as pi bonds. That's going to come from leftover p orbitals. So in our hybridization for sp, we saw that we actually only took one s and one p orbital to make two sp orbitals, and then we left two unhybridized p orbitals were left over. So those are going to be these two here. So if we look at this visually, we see that we have the one s and it combines with one p. That will give us those two sp orbitals. And then there's going to be two of the actual p orbitals that are left over. How these are going to orient, so first with the sp orbitals, we want them to be as far apart as possible, just like all the other hybridized orbitals, we wanted them to be as far apart as possible. And here, the way that we can do that with only two orbitals is actually 180 degrees. So completely on opposite sides of that carbon, that's going to be as far apart as they can get. And that's something that we're going to see with our sp hybridization. So that kind of, those hybridized orbitals set the stage for what that shape is going to be around the carbon. And so that's why for our line structures, for example, when we were drawing triple bonds, we had to draw them completely straight and the bonds on either side of the triple bond completely straight. And that's because this is all set from the sp orbitals needing to be linear. For these, though, we don't just have those hybridized orbitals, we also have two p orbitals that are left over. They each have an electron as well, and so we have to take care of those. And so what they're going to do is they're going to orient themselves at 90 degrees to all the other orbitals. So this purple p orbital is going to orient itself 90 degrees to the sp orbitals, as well as 90 degrees in a different direction to the other p orbital. So it's going to be 90 degrees from everything in space. This blue p orbital is going to do the exact same thing. It's going to be orienting itself 90 degrees to everything as well. And so that's what's going to happen with those leftover p orbitals. But we also are going to have to think about how is this carbon going to now make a bond with the other carbon. So this was our molecule that we were dealing with. And what we are going to have is these carbon atoms kind of connected to each other, but also connected to a hydrogen. So I've gone ahead and put all the atoms in here. Let's start drawing in the orbital. So we said that the left-hand carbon is going to have an sp orbital, and then 180 degrees away, another sp orbital. Same thing's going to happen with the right-hand carbon. So that's going to have an sp orbital, and then another sp orbital. So we can go ahead and label those if we want. And then our hydrogens are going to come in with their s orbitals. And then what's going to happen, we're going to have to deal with all those p orbitals, those leftover p orbitals. So we're going to have the purple p orbital be oriented in one direction on the one carbon, and on that same direction, we're going to show this with another purple p orbital on the other carbon. So that's going to be, those are our p orbitals, and that's going to be one of our pi bonds. The other one is going to come from the blue p orbital. So we're going to draw this one going out of the page on the one side and going into the page on the other side. And again, these are two different phases, and so that's how we're also shading in. So we're going to have the p orbitals, we'll just label them in their unshaded phases, those at the back. So one of the pi bonds is going to be made from the side-to-side overlap of the blue p orbitals, and then in the other orientation, we have the purple p orbitals, which are going to make up the other pi bond. So there's going to be a pi bond made up from the purple orbitals, a pi bond made up from the blue orbitals, and then we're still going to have our sigma bond between the carbon and the hydrogen, a sigma bond between the two carbons holding them together, and a sigma bond between the other carbon and the hydrogen. So if we were to label that on our structure here, we would have a sigma bond between the carbon and the hydrogen on either side, made from the sp orbital of each carbon overlapping with the s orbital of each hydrogen. Then we're also going to have in the middle between the two carbons, that's where we're going to have multiple bonds. We're going to have the sigma bond from the two sp orbitals overlapping from the carbons. Then the carbons are going to overlap one of their unhybridized p orbitals with each other, so the purple ones, for example. Then they're going to overlap their other unhybridized p orbitals with each other, so that's going to make another pi bond. So this triple bond is going to be made up of a sigma and two pi bonds, the purple and blue in this case. And so it doesn't really matter where we label them. Let's just say we're labeling one line the sigma, another line the blue pi bond, and then the last line is representing the purple pi bond. So basically we're going to have a triple bond as a result of one sigma bond and two pi bonds. Where we saw that double bond, carbon-carbon double bond, was a sigma bond and one other pi bond. And then with our first example with sp3, we didn't have any pi bonds at all. We just had sigma bonds, so just single bonds. So that's how we would draw out the sp hybridization and in the molecule. Next, we're going to talk about resonance and how that has to do with molecular orbital theory. And we'll come back to figure out by just looking at a molecule, how would we know what that hybridization is going to be? And we're going to have to take into consideration what all atoms the atom that we're looking at is attached to figure out our hybridization. We're going to have to consider if there's any lone pairs, and we're also going to have to consider if there's any resonance. So we'll talk about that after we talk about the resonance in molecular orbitals.